Hello, my name is Rod Kowicki. You probably saw a few of my videos. I'm not a very good video maker, but I can talk. And I'm learning more, with those little tricks that they got on those apps. Pretty good. But anyways, I've been doing research trying to find out how it is that people can generate the idea that the speed of light is the fastest you can travel when it's been shown that, for one, that the universe is traveling faster than light. Anyways, I started thinking, this took years because I researched everything I could on this because I never could believe that there was a light constant. Einstein called it the cosmological constant, that nothing can travel faster than light. And as such, he indicated that the universe was apt to the same thing, that the universe is traveling, that gravity is traveling at the speed of light. And I started thinking, if that's true, then the universe is an actual light bulb. And light doesn't travel, it's fixed. So that means it's fixed at traveling at the speed of itself. That's what fixed means. And so if the universe was fixed at the speed of light, then light couldn't travel. And in relativity, it says that light travels throughout the universe. So you got a light beam, or whatever you want to call it, and then you have the universe. Let's say dark space, then you got the planets and stars and all that stuff. So we go out of the perimeter, we go into the galaxies. The space between the galaxies is where FTL was discovered. It was discovered in 1943 that the universe was traveling faster than the speed of light. In 1913 and 1915, Einstein formulated his theory that's saying that the speed of light was the fastest you could travel. So we have this blunder. We blundered everything. But at the time, people were really in there. So we got, 20 years that they kept on researching all this stuff. But there's a part in there where he talks about, and he shows that starlight travels up and around these curves to get from one place to the other, even if it's traveling at the speed of light. Which means that even light has a Doppler effect. Accordingly, if you could pick it up, if there's enough energy between, they use between the galaxies to find out Doppler effects. But let's say a ship traveling at the speed of light it's small. We're talking about the difference between, your light bulbs and your frequencies, your light frequency and your dark frequency. But then I started thinking, I says, then light can't travel through space. It's intermediate of itself. It stops there. It can't travel. Think about it. It cannot travel if that's its limit. And if the universe is in the same dilemma, it can't travel because the universe, space itself, is traveling at the speed of light. When you go into a room, a dark room, and turn on the light, it's fixed, bam. That's your frequency and that's your light, right? And it can be brighter and it can be softer, you know. So we have your frequency, but it's fixed between the soft and the bright. You know, it can blind you, be so bright it blinds you, or it be so soft you can barely, you know, you can barely see. But in space, if light travels, then the universe ain't fixed. That means that the universe is traveling faster than the speed of light. And nobody has made these assumptions, you know. And it might be a small one, but, you know, beside the fact that it's been measured, that the universe is traveling faster than light, there's a couple things that I think they didn't look over, or it's all part of research, you know. And they just don't, I don't know, you know. I did all this research on my own. I've written 4, 5 books on gravity and the speed of light. And in those books, I go through all the possibilities of most of the theories they have about light and why it's fixed and why we can't go travel faster. But light is traveling and takes time to get from one place to the other. When I'm talking about light by itself, you know, even light from a mass, you know, it travels. That mass can travel faster than the speed of light because light travels. That means the universe is not fixed. And if it's not fixed, we can travel faster than the speed of light. That means that, no, there's no time travel. And most of your gravity theories are based on matter, not space. And matter and light are the same things because it's mass that projects the energy in matter. You know, matter is made up of a certain amount of energy, and each mass and its size only takes up a certain amount of energy depending on what it is and how big it is, you know. A 12-volt battery can be the size for a car, or it can be as big as a house, you know. It's just how much storage in there. So you can look at space as being the storage and light as being the energy, you know. How much energy we have, you know. So then we go back to Isaac Newton's theory and say, well, we double the energy, which means we double the proportion value and we can travel faster, you know. So that's kind of like what I've done. I took all these theories and tried to find a loophole, and it's, you know, aside from the ones that I've read about that are out there, light is fixed yet travels at a certain velocity, but it travels. So the universe is not fixed, and we can travel faster than the speed of light. That's about as far as I go right now, you know, but it's reality. FTL is possible. Light is fixed, and it's slower than what the universe is traveling. And the proof of this is that light travels. It takes light time to travel from one place to the other, yet it's traveling at the speed of light. Which means, since it's traveling, that the universe somehow is not fixed with light. And if it's not, and it is, the universe is fixed, then it depends on the frequency. Okay, Einstein says, okay, the max frequency is 186,000 miles a second. But like I says, the universe, space is the storage, and light is the energy. And light travels through the universe because it's so big, let's say. But it also means that it's not fixed. We talk about infantry, and particles, random particles of light, let's say, and how much energy that is, what the frequency is, and how fast they travel. So what's this all really mean? The universe is not fixed. Light is fixed, but the universe is. That means that if the universe is fixed in the way Einstein evaluates his theory on E equals mc squared, then as soon as the light is maximized, it would travel from one end of the galaxy to one end of the universe to the next. So according to Einstein's theory, the universe is very small. It's relevant to the speed of light. Now we can square it. You can square it and try to find the density and all that stuff, but it's actually small. Okay, everything's consumed and concentrated to the speed of light. This is the way we see it. The planets are actually, there's no space between them, according to the Doppler effect and at the speed of light. Now we know that's impossible. We're traveling so fast we just can't see it. We gotta coordinate our coordinates to where we're traveling through this dark mass. But besides all that stuff, if the universe was fixed at the speed of light, then, relative to planets or even space between galaxies, it's instantaneous. Okay, light is instantaneous, fine, but space isn't. And that means that light, when you switch it on, it doesn't light up the universe. It lights up only the sections that it's got. So the universe is actually quite small. And it's not fixed. That was Einstein's theory. There's other discrepancies about how to mathematically define the speed of light and gravity and all those things, relative to Earth gravity and space gravity, but it's not fixed. Light travels, which means that it's not small. It's not, actually, it's probably not even shrunk. Well, actually, it doesn't shrink, We're talking about a hypothesis. So in actuality, the reality is it doesn't shrink. That's a lot of damn space. And I don't care how fast you're traveling. Okay, from here to the moon is 250,000 miles, right? Bam, we travel at the speed of light. We do it in a quarter of a second. According to relativity, if we travel at the speed of light, there's only a second involved. There's nothing smaller than a second. If time travel is possible, let's say, okay, we're talking about seconds, we're not, but we know that there's time smaller than seconds. So we could look at the speed of light and the universe as not being the same. The density of the universe is bigger. Light travels. It's not light is instantaneous to itself. In other words, it travels at one velocity. I hope you get something out of this. I'm trying to find a logical means to show that the universe is not fixed. And if it takes light such and such time to get there. But that's what it means. It means that the universe is fixed at the speed of light. And light and space are the same thing. That's what he said. But they aren't. And that's his blunder.